Hello again. Now I'm going to talk about networking and IP addresses here, but it follows on from part one of this where I just gave an overview. So if you haven't seen that video, just check that out first. Anyway, we'll rip straight into this. Now if you've been following along this series, you'll know that I gave Proxmox the IP address 192.168.0.100. Okay. Now if you watched my video on hexadecimal and binary, you'll know how to convert that to binary, which is what we've got to do. So in binary, that's 11000000 and dot to separate these things. 10101000 dot, and the 0 is obviously all zeros. And the last one. 10100100. Is that right? Yes. Okay, so that's what that is in binary. Now we also set a subnet mask, if you remember, and it was 255.255.255.0, and we'll write that in binary as well, which is obviously pretty easy. So 255 is just 11111111, and a little dot there. 11111111, little dot. 111111 dot 00000000. Okay, so as I said, that's our IP address, and this is our network mask. Okay. Now, if you look at the word mask, think about what a mask is. We got masking tape. So you use masking tape, don't you, when you're going to paint something, so you don't paint over that area. You mask it with masking tape. Well, it's the same sense of this word here, the mask. So what we're going to do here is a logical AND between the IP address and the subnet mask. So what I mean by that, if you look at the word AND, in digital electronics, for instance, you have a logic gate called an AND gate, and you've got two inputs and one output. Okay, and you'll only get the output set to 1 if both the first and the second input are 1. So they've both got to be 1 for the output to be 1, and that's what we're doing here. So if this bit and that bit are 1, then we'll get a 1 down here. So they're both 1, so we get a 1. They're both 1, so we get a 1. They're not both 1, so we'll get a 0. Is that and that 1? No. That and that? No. That and that? No. No, no. That and that? Yes. That and that? No. That and that? Yes. No. Yes. No, no, no. Dot. All the no's here. And is that and that? No. That and that? No, no, no. No, 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 no. Okay, so if you look at that result, this light blue one here, and put that back into decimal values here, we get 192.168.0.0. And that 192.168.0.0 is our network address. Okay, that's the identity of that network. So up here, this first one, this .100 that we had, okay, that was an actual host that we had on there. That's Proxmox in this network. Okay. But the network ID, the network itself, is 192.168.0.0. And by having that network mask there, that 255.255.255.0, okay, that told us, or that tells that host where its network begins and ends. So this host knows, because of its network mask of 255.255.255.0, it knows where its network begins and ends. So back to the monkey analogy, it knows which monkeys are in its own cage. Okay. Now, if it has to send to something that doesn't fall within the range of its network, it knows it has to go through a router. Okay. So the range of this network goes from .0 would be the minimum, and 255 would be the maximum. Now, we can't actually use 0 and 255 because 0 is, as I've just shown, the actual network address. Okay. That's it right there. That's the network address itself. And the highest value, in this case 255, is a broadcast, which means it goes to every host on that network. But basically, you've got 254 usable hosts in that network, and this knows where that boundary is because of the network mask here. Now, you might recall on pfSense, it wasn't written like 255, 255, 2550. We had a slash and a number. That simply refers to the same thing, but it's just talking about the amount of bits. So you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we can write 255, 255, 2550 simply by saying /24. It's just a shorthand way of writing the same thing. It tells you the network mask so that hosts know where their network boundary is and if they have to route the packet or not. So I will leave that there, and in the next video we'll do some actual hands-on, maybe with some Raspberry Pis, and see how this works in the real world. So until then, take it easy.